A tiny finger bone from Siberia revealed an entire human species no one knew existed.
Denisovans survived Ice Age Siberia for millennia. We carry their genes today.
They adapted to extreme cold and altitude in ways we are discovering now.
They thrived in frozen darkness, then vanished. Their DNA tells their story.
Welcome to Sapiens Untold. If you enjoy these explorations of humanity's mysteries, please like and subscribe. Where are you listening from tonight? Now, close your eyes and imagine standing at the very precipice of human discovery, amidst the biting winds of Siberia's Altai mountains. You are at the mouth of Denisova Cave, a vast, ancient sanctuary carved by millennia of ice, wind, and the patient drip of time. The air here is frigid, carrying the scent of damp earth, frozen rock, and the heavy silence of ages, a poignant counterpoint to the relentless Ice Age megafauna that once roamed this harsh landscape. For hundreds of thousands of years, deep within its silent chambers, amidst layers of frozen sediment, a profound secret lay undisturbed. It was here, in 2010, that an unassuming fragment of bone, barely larger than your fingertip, was carefully unearthed. This wasn't a grand skull or a complete skeleton, but a tiny phalanx, a piece of a finger bone, belonging to a juvenile female. For generations, mainstream archaeology believed our human story was largely a tale of Neanderthals and Homo sapiens, but this minuscule relic held a silent revolution. Genetic analysis performed on DNA preserved for over 50,000 years revealed something astonishing. This bone belonged not to a Neanderthal, nor to modern humans, but to an entirely new, previously unknown human species. The scientific detective story began. How do you reconstruct an entire human species from a fingertip? This single, frozen fragment from Denisova Cave, nestled in a remote, unforgiving landscape, became the cornerstone of a new chapter in human evolution. It hinted at a vast, untold story of our closest relatives, adapted to extreme environments in ways we're only beginning to understand, enduring the brutal Ice Age conditions of Siberia. We had walked the same Earth with them for hundreds of thousands of years, shared the planet as contemporaries, yet only now, from this solitary find, did we glimpse their existence. Most of what we know about these mysterious humans, whom we now call Denisovans, still comes from this single extraordinary cave, a testament to the power of ancient DNA. This tiny bone whispers of an immense, forgotten past. What other echoes of forgotten humanity lie buried in the world's most inhospitable places, waiting for a whisper of discovery? What profound questions does this minuscule fingerbone ask about our own human story, and the vast, intricate tapestry of human diversity we are only just beginning to unearth? Beneath the vast, star-dusted canopy of the Altai sky, a silent, unyielding cold presses down. Just as it did tens of thousands of years ago, you stand outside the ancient cave mouth, gazing across the sweeping frozen valleys, imagining a world where towering mammoths and woolly rhinos grazed under colossal glaciers. This was the stage for the Denisovans, a stark, unforgiving landscape that tested the very limits of human endurance. How did they not only survive, but thrive, in such a brutal Ice Age environment, where modern humans would struggle immensely? Further discoveries within Denisova Cave began to piece together a fragmented answer. Not long after the fingerbone, a molar tooth of extraordinary size was found. You examined photographs of this relic, noting its massive, robust structure, unlike anything seen in days with the Homo sapiens, or even Neanderthals. This single tooth offered a glimpse into a physiology built for a different world, suggesting immense jaws and a broader, more archaic facial structure than our own. Later genetic analysis, including DNA methylation patterns from the fingerbone, confirmed these initial suspicions, painting a picture of individuals with perhaps broad, flat faces, strong brows, and these enormous teeth, a stark physical contrast to the more gracile Homo sapiens. This evidence hints at a profound truth. The Denisovans were adapted to extreme environments in ways we're only beginning to understand. Their physical traits suggest a resilience perfectly suited for Ice Age Siberia, an adaptation forged over hundreds of thousands of years. Yet, most of what we know still comes from the scant remains within this single cave. A poignant reality, given the vast timeline of their existence. The revelation that multiple Denisovan populations existed across Asia, stretching from Siberia to Southeast Asia, deepens the mystery, suggesting a widespread, successful lineage that has left almost no fossil record. What did these massive-jawed, broad-faced relatives experience as they navigated the frozen darkness of their world? How many more fragments of their story lie buried, waiting to reveal the full tapestry of their ancient resilience and the secrets of their unique adaptations? You stand within the cool, hushed depths of Denisova Cave. The very air a testament to immense stretches of time. Each layer of sediment, meticulously excavated by archaeologists, holds a silent record of millennia. The earth here isn't just dirt, it's a frozen archive, a dense palimpsest of ancient lives. You watch as a geneticist, with almost surgical precision, carefully scrapes a tiny sample of soil, not seeking a bone, but the microscopic whispers embedded within the cave's very dust. This is the cutting edge of scientific detective work. How do geneticists extract 50,000-year-old DNA from cave sediments? The cold embrace of the Siberian earth acted as a natural freezer, preserving genetic material that would have long degraded elsewhere. Through revolutionary sequencing breakthroughs, scientists can now sift through environmental DNA, or eDNA, the shed cells, hair, and bodily fluids left behind by ancient inhabitants. Genetic analysis revealed the presence of Denisovan DNA in multiple layers, even where no bone fragments were found. This groundbreaking technique means we can detect the unseen, proving their presence and timeline purely from the microscopic traces left on the cave floor. This environmental DNA speaks volumes about their long occupation of Denisova Cave, often overlapping with both Neanderthals and early modern humans. It allows us to glimpse a long-lost chapter without the physical presence of a body. In a poignant reality, we know Denisovans existed, we carry their genes, yet we've found so few physical remains that all known Denisovan fossils could fit in a small box. Most of the evidence, beyond those rare fragments, comes from this, ghost DNA. Genetic signatures in modern populations, proving ancient interbreeding, even when we've never found the fossils. The ability to uncover entire human species from a fingertip, a tooth, or even just ancient dirt, reshapes our understanding of human history. What does it mean that modern humans interbred with at least 3 different human species, Denisovans, Neanderthals, and possibly others, leaving their genetic legacy within us today? How many other human species existed, living and intermingling with our ancestors, that left no physical trace at all, only whispers in the Earth's cold embrace, or hidden within the ghost DNA of living populations? Beyond the ancient cave, within the cool hum of a modern genetic laboratory, lies another realm of profound discovery. You watch a screen filled with intricate patterns of genetic code, a silent language translated from molecules tens of thousands of years old. This is where the true revolution began, as genetic analysis revealed not just a new human species, but their intimate connection to our own lineage. The DNA extracted from that single finger bone and later from other rare fragments painted an astonishing picture of interbreeding. Genetic analysis revealed unequivocally that Denisovans interbred with ancestors of modern humans. Today, we carry their DNA. Indigenous populations in Melanesia, for instance, often possess between 4% and 6% Denisovan ancestry, a vivid genetic echo of ancient encounters. Further studies showed their genetic influence extends to various Asian populations, including those in Southeast Asia and even remote parts of Siberia. This isn't just an abstract scientific finding. It means Denisovans, our close relatives, are quite literally a part of us. One of the most striking revelations concerns adaptation. Genetic variants inherited from Denisovans have been identified as crucial for human survival in challenging environments. Consider the people of Tibet, who thrive at altitudes where oxygen levels are dangerously low. Genetic analysis has shown that the Times EPAS1* gene variant, responsible for their remarkable high-altitude adaptation, originated from Denisovans. This raises a compelling question. Were Denisovans mountain specialists, masters of survival in thin air, who passed on this invaluable genetic gift to Homo sapiens? Their long presence in the Altai mountains, near the roof of the world, certainly suggests a profound resilience to extreme cold and altitude. This genetic inheritance from ghost DNA, signatures in modern populations proving ancient interbreeding, even when we have found no physical fossils, highlights a profound mystery. We know they existed, we carry their genes, yet their physical remains are so scarce. If we carry their genes, if their adaptations live on within us, are they truly extinct, or do they, in a profound genetic sense, still live on? What more do these whispers in our DNA tell us about the forgotten chapters of our own story? You trace a finger across an ancient map of Asia, not of modern borders, but of vast, undulating landmasses, marked by ice sheets and forgotten rivers. The silence of deep time hangs heavy as you consider the incredible journeys undertaken by early humans, traversing immense distances into unknown territories. It's here, in the sprawling expanse of this ancient continent, that the Denisovan story truly unfolds, far beyond the confines of a single Siberian cave. Genetic analysis, a remarkable feat of molecular archaeology, revealed not just one Denisovan population, but evidence of multiple distinct groups spread across Asia. This astonishing revelation challenges our previous notions of isolated human species, painting a picture of a vast and diverse hominin landscape. Their genetic signatures, preserved as ghost DNA in modern human populations, suggest a long and successful presence stretching from the frozen steppes of Siberia, down through the high plateaus of Central Asia, and all the way to the tropical islands of Southeast Asia. You ponder the sheer adaptability this implies, how a species could master such a vast array of environments, from extreme cold to humid tropics. The timeline of their existence adds another layer of intrigue. Evidence suggests Denisovans survived until potentially 30,000 years ago, a period during which they significantly overlapped with both Neanderthals and anatomically modern humans across the continent. You can almost feel the weight of these encounters, diverse human species sharing landscapes, resources, and even genes. Within the very layers of Denisova Cave, a place we've come to know so well, archaeologists have unearthed remains from all three groups, sometimes within the same stratigraphic layers. What happened in those caves, where three human species remains are found together? Did they share shelters, pass through the same hunting grounds, or perhaps exchange not just genetic material, but ideas and technologies? This widespread distribution and prolonged coexistence force us to reconsider the complexity of our human family tree. How many untold interactions, adaptations and migrations unfolded across this enormous continent, leaving only faint genetic whispers in their wake? What lost cultural wisdom, perfected over millennia in these vast, challenging landscapes, vanished with them, leaving only the profound mystery of their silent legacy? You stand before a magnified image of the Denisovan genome sequence, a long, intricate string of molecular letters. This silent strand of DNA, pieced together from ancient fragments, represents one of the most remarkable scientific feats of our age. It's here, in this digital realm, that the true visage of the Denisovans begins to emerge, not from fossilized bone, but from the very blueprint of life itself. The revelation of their distinct genetic lineage, separate from both modern humans and Neanderthals, fundamentally reshaped our understanding of the human family tree, introducing a major new branch we never knew existed. This full genomic sequencing provided a treasure trove of information, despite the paucity of physical remains. By comparing Denisovan DNA with that of modern humans and Neanderthals, geneticists could map their evolutionary journey and even infer physical characteristics. The reconstructions based on this DNA are striking. They suggest individuals with massive jaws, broad faces, and those enormous teeth we glimpsed from the single molar found in the cave. These inferences, drawn solely from the genetic code, offer a profound scientific mystery. How can you reconstruct an entire human species' appearance from such limited material? It highlights the immense power of DNA as a historical record. The profound mystery intensifies when you consider the haunting reality. We know Denisovans existed, we carry their genes, yet we found so few physical remains that all known Denisovan fossils could fit in a small box. Most of what we know comes from this, ghost DNA, genetic signatures in modern populations proving ancient interbreeding, even when we've never found the fossils. It's a poignant testament to their elusive nature. They walked the same earth as our ancestors for millennia, shared genes, perhaps even shared culture, and then vanished, leaving only whispers in our DNA, and these almost invisible fragments in frozen caves. What silent stories are still encoded within the precise arrangement of these ancient genetic sequences? If their DNA reveals so much about their appearance and adaptations, what more profound secrets of their lives, their societies, and their ultimate disappearance remain hidden within the silence of the strand, waiting for us to learn how to read them? Deep within the ancient layers of Denisova Cave, where the air itself feels imbued with echoes of the past, you hold a fragment unlike any other, a polished stone bracelet. It's a small piece, a mere curve of dark green chloritolite, yet its smooth, almost luminous surface speaks of immense skill and deliberate artistry. You turn it in your hand, feeling the subtle coolness of the stone, the faint gleam of its polished facets. This isn't just a tool, it's an ornament, found in archaeological layers associated with Denisovan remains, dating back approximately 40,000 to 50,000 years ago. The craftsmanship is extraordinary. Mainstream archaeology, until recently, attributed such sophisticated tool use and symbolic behavior almost exclusively to Tarcholpasosegans. Yet, this bracelet features a carefully drilled hole, a testament to precision drilling that would have required complex techniques, a rapidly rotating drill, and a stable platform, far more advanced than simple stone flaking. The surface itself is meticulously polished, a time-consuming process that goes beyond utilitarian function, hinting at aesthetic appreciation and perhaps personal adornment. This artifact forces a profound re-evaluation of Denisovan capabilities, pushing the boundaries of what we thought was possible for non-asterisk Homo sapiens hominins. Did Denisovans possess cognitive abilities and cultural practices, including symbolic thought and an appreciation for beauty, that rivaled or even preceded those of early modern humans? Or did they perhaps learn or trade these skills with contemporary Homo sapiens, or Neanderthals, who also inhabited these very caves? The truth is still shrouded in the silence of deep time, a captivating scientific mystery. The bracelet, along with other artifacts like bone tools and ostrich eggshell beads found in Denisova Cave, suggests a complex material culture. We know Denisovans survived in Siberia's harshest Ice Age environments, but these objects hint at more than just survival. They suggest a rich inner world. What stories of identity, status, or spiritual belief are held within this polished stone, a silent testament to the sophisticated minds that once navigated this frozen, ancient world? You turn a different artifact over in your hands within the cool quiet of Denisova cave. A precisely flaked stone tool, perhaps a scraper or a projectile point, retrieved from the same ancient layers that yielded the enigmatic bracelet. This isn't crude, rudimentary work. The edges are sharp, intentionally shaped, speaking volumes of a purposeful intelligence. This artifact, like others discovered here, including delicate bone needles, indicates sophisticated tool use and manufacturing techniques. For millennia, such advancements were largely attributed solely to Homo sapiens asterisk, yet these pieces from Denisovans depths rewrite that narrative, challenging our understanding of technological evolution in early human populations. These sophisticated tools, found alongside Denisovan remains, were essential for survival in the harsh, frozen landscape of Ice Age Siberia. Imagine hunting the enormous megafauna, processing their thick hides, or constructing shelters capable of warding off sub-zero temperatures. The bone needles, for instance, imply the ability to sew fitted clothing, a critical adaptation for life in extreme cold. This evidence points to a species adapted to extreme environments in ways we're only beginning to understand, exhibiting ingenuity and foresight crucial for thriving where others might perish. The very presence of these advanced artifacts raises profound questions about Denisovan cognitive abilities. Did they independently develop these complex technologies, demonstrating an inherent capacity for innovation and abstract thought? Or did their long period of overlap with both Neanderthals and early modern humans lead to a mutual exchange of knowledge and techniques? What happened in these caves, where multiple human species left their traces, suggesting periods of cohabitation or consecutive occupation over vast stretches of time? These tools are not just remnants of daily life, they are echoes of sophisticated minds. We grapple with the poignant reality that most of what we know about the Denisovans comes from a single cave, a handful of bone fragments, and the whispers in our own DNA. What other artifacts, hinting at their full range of capabilities and culture, lie undiscovered across the vast reaches of Asia? What stories of innovation and resilience do these silent stones tell about a human relative who mastered an unforgiving world? And what deeper lessons about human ingenuity do they hold for us today? You close your eyes, imagining a tapestry woven not from threads, but from strands of DNA, stretching back tens of thousands of years. Within this intricate genetic fabric of modern humanity, there are echoes, silent yet profound, of a lineage long vanished from the fossil record, the Denisovans. This is the ultimate scientific detective story, where the deepest mysteries are solved not with trowels and brushes in a cave, but with supercomputers mapping genetic code. We carry their DNA. This is the breathtaking revelation of the last decade, transforming our understanding of who we are. Genetic analysis has meticulously pieced together the story of ancient interbreeding events, proving that Homo sapiens asterisk ancestors encountered and interbred with Denisovans multiple times across Asia. Today, people in Melanesia, for example, carry a substantial portion of Denisovan genes, often between 4% and 6% of their genome. This isn't a mere statistical anomaly, it's a living legacy, a direct link to those enigmatic Ice Age relatives who once walked the Earth alongside us. Beyond just a presence, these inherited genes often conferred crucial advantages. As you consider the vast oxygen-thin plateaus of the Himalayas, remember the Tibetan people, uniquely adapted to high altitudes. Genetic analysis revealed that their remarkable ability to thrive in such environments is due, in large part, to a specific variant of the Times EPAS1* gene, a variant that originated from Denisovans. This suggests a profound truth. Denisovan survival in extreme environments offered our ancestors a crucial genetic toolkit, a biological shortcut to adapting to challenging landscapes. Were Denisovans perhaps mountain specialists, silent masters of the peaks and frozen wastes, whose genetic gifts allowed modern humans to expand into new territories. This genetic inheritance from ghost DNA, signatures in modern populations proving ancient interbreeding, even when we found no physical fossils, forces a redefinition of what extinction truly means. If we carry their genes, if their adaptations live on in us, are they truly extinct, or do they, in a profound genetic sense, still echo through the generations? What other unseen legacies, woven into our very cells, silently connect us to the myriad human species that once populated our mysterious past? You find yourself high in the thin, crisp air of the Tibetan plateau, where the vast ancient peaks pierce the azure sky. The wind, carrying the scent of distant glaciers and sparse mountain flora, whispers of an environment that demands incredible resilience. Here at altitudes where most humans would struggle profoundly, the indigenous people thrive, their bodies uniquely adapted to the scarcity of oxygen. This remarkable human feat holds a profound secret, a silent gift from our enigmatic relatives, the Denisovans. Genetic analysis, a marvel of modern science, has unveiled this extraordinary link. It revealed that the Times EPAS1* gene variant, which allows Tibetans to efficiently process oxygen at high altitudes, did not evolve independently within Homo sapiens. Instead, this crucial genetic adaptation was inherited directly from Denisovans through ancient interbreeding events. You grasp the significance. We carry their DNA, and in this specific instance, it conferred a life-saving advantage to a population facing one of Earth's most challenging environments. It's a vivid demonstration of how ghost DNA, genetic signatures in modern populations, proves ancient interbreeding and its enduring impact. This discovery paints a compelling picture of Denisovans as probable masters of extreme environments. Their presence in Siberia's Altai mountains, combined with this genetic legacy, suggests they were uniquely adapted to both high altitudes and extreme cold. They survived the brutal Ice Age in ways we're only beginning to understand, possessing physiological traits that allowed them to flourish where others would falter. Could they have been mountain specialists, moving across vast, elevated landscapes, holding within their genome the keys to surviving the world's highest places? The story of the Times EPAS1* gene is more than a scientific fact. It's a testament to the profound interconnectedness of our human family tree. These were our relatives, our contemporaries for millennia, who bequeathed a vital genetic legacy. What does Denisovan survival in extreme cold and high altitude teach us about the very limits of human adaptability? If we carry their genes, if their profound adaptations live on in us, do they truly disappear? Or do they, in some fundamental way, continue to shape our journey through time? You stand deep within the silent, ancient chambers of Denisova Cave, where the very air seems to hum with untold stories from the deep past. Layers of sediment rise around you, each a frozen testament to thousands of years, a unique archive where, not one, but 3 distinct human lineages left their mark. This cave is extraordinary, a rare meeting ground where Denisovans, Neanderthals and early Thais Homo sapiens * coexisted, sometimes overlapping across millennia. Tonight we contemplate the profound mystery of 2 of these groups, Denisovans and Neanderthals, living, breathing and perhaps even interacting within these very walls. Imagine the flickering firelight, the muffled sounds against the cold stone, as these 2 ancient populations sought refuge from the unforgiving Ice Age. Evidence within the cave points to long periods of occupation by both species. This isn't mere speculation. In a truly astonishing discovery, a tiny bone fragment, lovingly nicknamed Deni by scientists, was unearthed. Genetic analysis revealed something unprecedented. Deni was a first-generation hybrid, the daughter of a Neanderthal mother and a Denisovan father. This remarkable find provides direct, undeniable proof of interbreeding between these 2 distinct human species. sharing the same harsh, frozen landscape. This revelation forces us to reimagine the tapestry of human history. What did these encounters entail? Were they rare, isolated events, or more common occurrences born of necessity and curiosity? Both Denisovans and Neanderthals were adapted to extreme environments, masters of survival in ways we're only beginning to understand, enduring the bitter cold and challenging resources of Ice Age Eurasia. They must have been incredibly resilient, using sophisticated tool use to hunt massive megafauna and find shelter from extreme temperatures. Denisova Cave holds the key to these intimate interactions, hinting at a shared history more complex and intertwined than previously imagined. What could it have meant for a child like Deni to be born of two such distinct lineages? What knowledge, culture, or even language might have been shared between these different branches of the human family? And why did one species ultimately vanish, while the other, through its hybrid descendants, quietly contributed to the genetic legacy that endures within us today? You hold a single ancient molar in your hand, retrieved from the deep frozen layers of Denisova Cave. It is surprisingly massive, far larger and more robust than any tooth you would find in a modern human, and even exceeds the typical size of Neanderthal molars. You run your finger over its cusps and roots, feeling the sheer scale of this single, poignant fragment. This dental clue, alongside the tiny finger bone, became one of the first physical glimpses into the unique morphology of the Denisovans, illuminating just how physically distinct they were from our own species. The unique morphology of this tooth, with its large divergent roots and complex crown structure, speaks volumes about a powerful jaw and perhaps a diet that required considerable chewing strength. Combined with reconstructions based on genetic analysis, this molar suggests that Denisovans possessed broad faces, strong brows, and these enormous teeth, a physiology built for the rigors of an Ice Age world. Their physical differences from Taj Homo sapiens asterisk hint at a specialized adaptation to their challenging environments, allowing them to process tough, fibrous foods or endure extreme cold in ways we are only beginning to understand. This examination deepens the scientific detective story. How do we infer an entire human species, appearance and lifestyle from such sparse physical evidence? The tooth, like the fingerbone, provides tangible proof. But it is the invisible, ghost DNA in modern populations that fills in the broader picture of their existence. It's a striking contrast. We have a robust genetic blueprint for an entire species, yet we can count their known physical remains on the fingers of one hand. All known Denisovan fossils could still fit into a small box, making this molar an incredibly precious window into their physical reality. What further secrets of their lives, their resilience, and their world might be held within the microscopic structure of this ancient tooth? Did their formidable dentition contribute to their survival in Ice Age Siberia, allowing them to exploit resources inaccessible to other hominins? What other physical traits did they possess, hidden from us by the vast silence of time, that enabled them to thrive in a world that modern humans would find utterly inhospitable? You stand at a metaphorical vantage point, high above ancient Asia, gazing not just at the Altai mountains, but at the sprawling, diverse landscapes stretching eastward and southward across the vast continent. The wind here carries the scent of untold distances, from glacial peaks to humid forests, a silent testament to journeys taken by early human relatives we are only just beginning to comprehend. Our focus shifts from the intimate confines of Denisova Cave to the profound implications of a species that truly mastered a continent. Genetic analysis, painstakingly performed on those precious fragments from Siberia, and, more strikingly, from the genetic echoes within modern populations, revealed an astonishing truth. There wasn't just a Denisovan population, but evidence of multiple, genetically distinct Denisovan groups. These ancient relatives were not confined to the frozen north. their genetic signatures suggest a widespread presence across Asia, from the frigid steppes of Siberia to the warmer climes of Southeast Asia. It means they were incredibly versatile, adapted to extreme environments in ways we're only beginning to understand. Imagine these nomadic people, their massive jaws and robust builds suited for endurance, traversing vast distances, perhaps following Ice Age megafauna, or exploiting diverse ecological niches. How did they survive Ice Age Siberia, moving across its frozen landscapes, when even Homo sapiens struggled to penetrate such depths? And how could the same species flourish in potentially tropical zones, leaving genetic traces in populations as far-flung as Melanesia? Their nomadic life must have been one of profound resourcefulness and adaptability, a mastery of survival over hundreds of thousands of years. Most of what we know about their widespread existence comes from ghost DNA, genetic signatures in modern populations proving ancient interbreeding, even when we've never found the physical fossils of these various groups. It's a poignant reality, a successful widespread human species that existed for millennia, yet remains almost entirely unknown through conventional archaeological means. What hidden routes did they take? What ephemeral camps did they establish across this enormous ancient land? What strategies did they employ to navigate such disparate environments? And what secrets of their journeys across Asia are still held within the vast, silent tapestry of the land itself? You feel the subtle hum of ancestry within your very cells, a deep, silent resonance that connects you to the vanished past. The story of the Denisovans, once confined to fragments of bone, truly blooms in the revolutionary science of DNA sequencing, revealing profound interconnections between disparate branches of the human family tree. Here the mystery deepens. Not only did they exist, but they interbred with our Homo sapiens ancestors, leaving an indelible genetic imprint that lives on within us today. Genetic analysis revealed unequivocally that modern humans carry Denisovan DNA. Look to the resilient indigenous populations of Melanesia, where a significant percentage of their genome, often between 4% and 6%, can be traced directly back to ancient Denisovan encounters. This genetic echo extends across various Asian populations, from the high plateaus of Tibet to the island nations of Southeast Asia. This isn't just a historical footnote, it's a living biological legacy, a testament to the fluidity and complexity of early human interactions. The implications of this widespread interbreeding are profound. It means that the human story is not one of neat, isolated lineages, but a rich tapestry of interwoven destinies. The Times EPAS1* gene, which confers high-altitude adaptation to Tibetans, is a powerful example, a gift of survival from Denisovans, enabling our ancestors to thrive in environments that would otherwise be inhospitable. This illustrates how beneficial traits, honed over millennia in one hominin species, could be rapidly acquired by another, accelerating adaptation. We are, in essence, a mosaic of these ancient encounters. What does it mean that modern humans interbred with at least 3 different human species, Denisovans, Neanderthals, and possibly other, even older ghost hominins? This challenges simplistic notions of a single linear human evolution, revealing a vast, interconnected network of shared genes and shared experiences. We know Denisovans existed, we carry their genes, yet we've found so few physical remains. If their remarkable adaptations and very essence continue to live on in us, if their whispers are encoded in our own DNA, are they truly extinct? Or do they, through us, continue their silent journey across the vast expanses of human time? You stand before a profound void, an empty space where the face of an entire human species should be. We possess their genetic blueprint. We carry their ancient code within us, yet their physical form remains largely shrouded in the mists of deep time. How do you reconstruct an entire human species from a fingertip and a single tooth? This is the core of the scientific detective story surrounding the Denisovans, a painstaking endeavor to piece together a fragmented mirror. Our most vivid imaginings of what Denisovans looked like emerge not from complete skeletons, but from the revolutionary science of ancient DNA. Through cutting-edge sequencing breakthroughs, geneticists have analyzed what are known as methylation patterns in their ancient DNA. These epigenetic markers, like subtle instructions etched into the genetic code, provide clues about gene activity and can, surprisingly, predict physical traits. Genetic analysis revealed a striking portrait. Reconstructions based on this DNA suggest individuals with massive jaws, broad faces, and those enormous teeth we glimpsed from the molar found in Denisova cave. It's a profound testament to the power of molecular biology to paint a picture where fossil evidence is almost non-existent. This inferred appearance, robust and formidable, speaks to a species exquisitely adapted to extreme environments. Imagine them navigating the Ice Age landscapes of Siberia, their powerful physiques and large dentition perfectly suited for a world of challenging resources and brutal cold. They survived in ways we're only beginning to understand, their very bodies a testament to millennia of adaptation. Yet, despite these incredible genetic insights, the poignant reality remains. We know Denisovans existed, we carry their genes, but all known Denisovan fossils could still fit in a small box. Most of what we know comes from this ghost DNA, from the whispers in the genetic code, rather than tangible bones. What more would this fragmented mirror reveal if we possessed a full skull, a complete skeleton? What stories of their lives, their resilience, and their interaction with the harsh world would be etched into their very features, currently hidden from us by the vast silent stretches of geological time? You stand at the threshold of a profound silence, contemplating the ultimate mystery of the Denisovans, their disappearance. They thrived for hundreds of thousands of years, mastering the harshest environments on Earth, leaving their genetic signature within us, yet their physical presence vanished from the world, leaving only fragments of bone and DNA to tell their story. The chilling question hangs in the cold Siberian air. What led to the quiet, almost imperceptible extinction of a human species so remarkably resilient? Evidence suggests that Denisovans survived until potentially 30,000 years ago, placing them squarely in a period of overlap with both Neanderthals and anatomically modern humans across Asia. This overlap means they were contemporaries, sharing landscapes, resources, and perhaps even cultural exchanges for millennia. But as Homo sapiens expanded, the Denisovans, like the Neanderthals, receded into the shadows of history. Did modern humans contribute to their extinction, perhaps through competition for dwindling resources in a changing climate? Or did climate shifts alone, the relentless ebb and flow of ice ages, finally erase them from the fossil record? The true answer remains one of science's most compelling mysteries. We know Denisovans existed, we carry their genes, yet their physical remains are so few that all known Denisovan fossils could still fit in a small box. This poignant reality intensifies the intrigue around their vanishing. Most of what we understand about their decline comes from their ghost DNA, genetic signatures in modern populations that prove ancient interbreeding, indicating their legacy lives on, even without their physical presence. It's as if their genetic whispers are stronger than their fossilized screams. We can reconstruct their massive jaws and broad faces based on DNA, but we cannot witness their final departure. What happened in the quiet caves and vast landscapes where three human species once coexisted, only for two to ultimately disappear? What stories of struggle and survival, of encounters and farewells lie buried in the frozen earth, waiting to be uncovered? If we carry their genes, are they truly extinct, or do they, in a profound genetic sense, still live on in us? What would we learn about our own adaptability and our place in the web of life if we could finally understand the complete story of the Denisovans? Last stand. You sit amid stacks of scholarly articles and flickering screen light, the quiet hum of research equipment, a modern counterpoint to the ancient silence of the Altai mountains. Here, in the realm of academic pursuit, the Denisovan story, while extraordinary, remains a constant challenge, a dynamic mystery reshaped with every new discovery. The scholar's dilemma is palpable. How do we navigate the controversial dating and competing theories that continuously redefine the prehistory of these elusive human relatives? The challenge begins with the very timeline of their existence. While genetic analysis places Denisovan occupation in Denisova cave over a vast span, precise dating of individual finds and associated artifacts is often complex and subject to revision. You examine graphs depicting stratigraphic layers, each tiny bone fragment and tool point requiring meticulous dating using techniques like optically stimulated luminescence for sediments or radiocarbon dating for organic materials. The ranges can be wide, spanning tens of thousands of years, leading to lively debates among researchers. For instance, some artifacts hinting at symbolic behavior have dates that stretch the accepted timeline for such complexities, prompting questions about which hominin created them and when. This constant push and pull between cutting-edge archaeological and genetic evidence fosters an environment of open-minded curiosity, but also uncertainty. Mainstream archaeology relies on these careful dating methods, yet new breakthroughs often necessitate re-evaluations. The very definition of a Denisovan artifact, for instance, is an evolving question. Are the sophisticated tools and the polished bracelet, found in Denisova cave, unequivocally Denisovan, or might they have been crafted by contemporary Neanderthals, or even early Homo sapiens *, who briefly occupied the same cave? This constant scholarly interrogation underscores a profound truth. Much of what we know about Denisovans remains in flux. We have fragments, we have their DNA, and we have hypotheses, but the full narrative is still being written, often with significant gaps. What does it mean that our understanding of an entire human species is so dependent on such limited, often debated evidence? How do we synthesize the precise data from genetics with the often ambiguous insights from archaeology to construct a truly coherent picture of a lost world? You stand amidst the whisper of ancient pines in the Altai mountains, feeling the chill of the Siberian air, but also the subtle warmth of human stories carried across generations. Beyond the scientific laboratories and archaeological trenches, a different kind of history exists here: the indigenous oral traditions of the local communities. These narratives, rich with myth and legend, speak of deep time, of powerful beings, and of different kinds of Hakti, forest people, who once inhabited these very lands. You listen, not for scientific fact, but for echoes of an ancestral memory that might connect, in alternative interpretations, to the enigmatic Denisovans. These indigenous accounts often describe ancient, robust inhabitants, sometimes depicted as strong, resilient figures, intimately connected to the land and its harsh rhythms. While these stories are not direct historical records in the Western scientific sense, they offer a profound perspective on how local populations remember and relate to the deep past of their home. Could these myths, passed down through countless generations, hold the faintest whispers of encounters with a robust, powerful hominin like the Denisovans, who were indeed adapted to extreme environments, and whose DNA we now know runs through the veins of many Asian populations? The scientific evidence, though distinct from oral tradition, paints a complementary picture of resilience. We know Denisovans possessed massive jaws, broad faces, and enormous teeth, reconstructed from their genetic makeup, suggesting a formidable presence. They survived Ice Age Siberia, when modern humans often struggled, showcasing a remarkable ability for adaptation to extreme cold and challenging landscapes. Their widespread presence, indicated by ghost DNA, in modern populations across Asia, further cements their enduring influence, even as their physical remains remain incredibly scarce. This interplay between scientific discovery and cultural memory evokes a profound sense of wonder. Could these ancient narratives, flowing like the rivers through the Altai, carry forgotten impressions of our elusive relatives? What stories would the Denisovans themselves have told of surviving the Ice Age in Siberia's frozen darkness? And what lessons might be gleaned from respectful consideration of how different ways of knowing can enrich our understanding of humanity's complex and mysterious past? Bridging the vast chasm between ancient whispers and cutting-edge genetic insights, you carefully examine a collection of artifacts, not under the biting Siberian wind, but in the hushed, climate-controlled environment where ancient history is meticulously preserved. Among them, a fragment of a dark green chloretolite bracelet shines with an unexpected luster, its surface polished to a remarkable sheen. Alongside it are delicate bone needles, intricately worked and precisely flaked stone tools. These objects, unearthed from the very layers of Denisova cave that yielded Denisovan remains, speak volumes beyond mere survival. They hint at a profound ancient engineering mind at work. The craftsmanship is astonishing, particularly for a human species only recently discovered and known primarily from genetic material. The polished bracelet, dated between 40,000 and 50,000 years old, features a precisely drilled hole. Such precision drilling required not just skill, but sophisticated techniques involving a rapidly rotating drill and a steady hand, far exceeding what was once thought possible for any hominin other than Homo sapiens at that time. Similarly, the bone needles suggest the creation of finely tailored clothing, an absolute necessity for surviving Ice Age Siberia's extreme cold, and a sign of complex foresight and dexterity. This cutting-edge archaeological evidence raises profound questions about Denisovan cognitive capabilities and symbolic behavior. These were not just utilitarian objects for basic survival, they imply an appreciation for aesthetics, personal adornment, and the deliberate investment of time and skill beyond immediate needs. Did Denisovans develop these advanced capabilities independently, demonstrating a complex intellect previously underestimated? Or did they engage in rich cultural exchanges with contemporary Neanderthals or early modern humans, leading to a diffusion of advanced technologies and artistic expression across the ancient landscape? Most of what we know about the Denisovans comes from a single cave, yet these artifacts broaden our understanding, revealing a species capable of remarkable ingenuity. What other technological innovations, perfected over hundreds of thousands of years of survival in some of Earth's harshest environments, lie undiscovered? What does the existence of such advanced objects tell us about the inner lives and cultural sophistication of these enigmatic relatives, who, through their ingenuity, mastered the brutal Ice Age world? You lean back, the quiet hum of distant thoughts filling the space around you, contemplating a profound shift in our understanding of humanity. The very existence of the Denisovans, revealed so suddenly in 2010 from a tiny fingerbone in a Siberian cave, serves as a powerful lesson in scientific humility. It forces us to acknowledge how much we still don't know about our own family tree, and how readily our long-held assumptions about human history can be gently yet utterly reshaped by a single silent discovery. For centuries, our human story seemed relatively clear, a tale primarily of ties Homo sapiens and Neanderthals. Then, from the frozen depths of Denisova cave, a new player emerged, an entire human species previously unknown to science. This scientific detective story, reconstructing an entire hominin lineage from a fingertip, a tooth, and later from DNA extracted directly from cave sediments, is a testament to groundbreaking ingenuity. It underscores the astonishing reality that we shared the planet with these relatives for hundreds of thousands of years, contemporaries who walked the same Earth, yet they remained almost completely unknown to us until a mere decade ago. The Denisovans were masters of adaptation, enduring the brutal Ice Age conditions of Siberia's Altai mountains, thriving in environments where modern humans struggled. We carry their DNA today, a living genetic testament to their enduring legacy, notably in populations in Melanesia and among Tibetans, who inherited crucial high-altitude adaptations from them. This ghost DNA, genetic signatures in modern populations proving ancient interbreeding, even when we've found no more physical fossils, paints a picture of multiple Denisovan populations spread across Asia, a vast and successful lineage that nevertheless vanished, leaving only these whispers in our genes. Their discovery raises profound echoing questions. How many other human species existed that left no trace in the conventional fossil record, known only through their fleeting genetic echoes, or yet to be discovered fragments? What does the Denisovan survival in extreme cold teach us about the true limits of human adaptability? If we carry their genes, if their profound adaptations live on in us, are they truly extinct, or do they, in a deep and enduring sense, continue to shape our journey through time? What unknown wonders still lie hidden in the vast silent archives of Earth, waiting to reveal the full, complex tapestry of humanity's extraordinary past? You find yourself kneeling at a carefully illuminated section within Denisova Cave. The air cool and still, rich with the scent of ancient earth. Before you, a paleoanthropologist works with a small trowel and a fine brush, meticulously scraping away layers of sediment, each grain a silent witness to millennia. The process is slow, almost meditative, a testament to the immense patience required to unearth the stories buried beneath countless years of geological time. Each cubic centimeter of Earth is sifted, examined, and documented, a painstaking quest for the almost invisible. This is the meticulous work that ultimately led to the world's knowledge of the Denisovans. Imagine the focus, the silent concentration, as that tiny finger bone fragment, belonging to a juvenile female, was first spotted amongst the detritus, indistinguishable to the untrained eye from countless other small stones. And later, the robust molar tooth, a profound physical clue to a new human species. It's a scientific detective story of the highest order, where vast implications hinge on the recognition of the smallest anomalies. How do you reconstruct an entire human species when most of what you have are fragments that could fit in a small box? The preservation of these remains in the frozen depths of Siberia's Altai mountains is a crucial factor. The extreme cold, a constant companion in this environment, acts as a natural guardian, slowing degradation and holding ancient DNA in a suspended state. This allowed for the revolutionary genetic analysis that transformed these inconspicuous fragments into the defining evidence of a new lineage. It emphasizes the profound role that environmental context plays in unlocking the secrets of the past, making these inhospitable caves paradoxically ideal archives. This painstaking journey from sediment to story highlights a poignant reality. We know Denisovans existed, we carry their genes, yet we've found so few physical remains. What other minuscule, overlooked fragments lie hidden within the untouched sediments of this cave, or others across Asia, waiting to unveil more of their elusive story? What further mysteries about our own human family, about who we were and who we became, remain buried, guarded by the very earth itself, waiting for such meticulous and patient hands to find them? You stand in a quiet laboratory, the hushed environment, a stark contrast to the biting winds of Siberia. Before you, meticulously arranged, are casts of precious fragments, the tiny finger bone, perhaps no larger than your smallest digit, and a surprisingly robust molar. These are among the few direct physical windows we possess into the Denisovans, a human species whose very existence remained unknown until a decade ago. To truly understand them, we must become anatomical detectives, comparing these scant clues to the more extensive skeletal libraries of Neanderthals and Taurosaurus. The finger bone, though small, provided the first crucial genetic evidence, but offered little about overall physique. It is the molar tooth, discovered in Denisova cave, that offered a more tangible, yet still fragmentary, clue. You examine its cast, noting its massive size and complex cusp patterns, characteristics distinct from both our own species and Neanderthals. This tooth strongly suggests immense jaws, a broader facial structure, and a powerful chewing apparatus, a stark contrast to the more delicate features of Homo sapiens. Reconstructions based on advanced genetic analysis, specifically methylation patterns in their DNA, further support this picture. Individuals with broad faces, strong brows, and those notably large teeth. Comparing these inferences to Neanderthal remains, we see shared robusticity, a common adaptation to Ice Age Eurasia, yet distinct differences. Neanderthals had prominent brow ridges and large nasal cavities, while Denisovan reconstructions hint at a broader, flatter face. These subtle yet significant differences, gleaned from such limited physical evidence and enriched by cutting-edge genetic insights, underscore the profound diversity within the human family tree. It's a scientific detective story where vast anatomical distinctions are pieced together from almost microscopic evidence, challenging us to imagine what these powerful, resilient relatives truly looked like. We know Denisovans were adapted to extreme environments, surviving Ice Age Siberia in ways we're only beginning to understand. Did their unique skeletal features contribute directly to their survival in these harsh conditions, allowing them to excel where others could not? What more would a complete Denisovan skull or skeleton reveal about their specialized adaptations, their everyday lives, and their profound place within the complex tapestry of ancient humanity? You stand at a metaphorical crossroads of deep time, tracing invisible pathways across an ancient map of Asia. The wind here carries not just the scent of distant mountains and forgotten forests, but also the silent echoes of unseen migrations, journeys undertaken by our elusive Denisovan relatives. It is a profound mystery how a human species, known primarily from a single Siberian cave, could have left its genetic fingerprints across such a vast and varied continent. Genetic analysis, a triumph of modern science, revealed a startling truth. The Denisovans were not an isolated, singular population. Instead, evidence suggests the existence of multiple, genetically distinct Denisovan populations, spreading across a vast swathe of Asia. Their ancient genetic signatures, preserved as ghost DNA in the genomes of modern humans, stretch from the frozen reaches of Siberia's Altai mountains, down through mainland Asia, and all the way to the tropical islands of Southeast Asia and Melanesia. This implies an extraordinary capacity for movement and adaptation, challenging previous notions of early human dispersal. Imagine these robust, broad-faced relatives, whose physiological adaptations allowed them to survive Ice Age Siberia, also navigating the humid jungles and diverse ecosystems thousands of miles away. They were adapted to extreme environments in ways we're only beginning to understand, a testament to their incredible resilience and resourcefulness. Yet, despite this extensive genetic footprint, the physical evidence of these widespread populations remains almost entirely absent. Most of what we know about their extensive movements and varied populations comes solely from the whispers embedded within our own genetic code. This stark contrast between widespread genetic legacy and profound fossil scarcity deepens the scientific mystery. What were the specific migratory paths these various Denisovan groups followed across ancient Asia? How did different populations, adapted to such disparate environments, maintain their genetic distinctiveness, even as they periodically interbred with migrating Homo sapiens? What untold stories of endurance and adaptation lie hidden within the vast landscapes they once traversed, their journeys now revealed only as unseen migrations etched into the very fabric of our shared humanity? You stand on a windswept ridge in the Altai mountains, the crisp, cold air biting at your cheeks. Above you the vast ancient peaks loom, their snow-dusted summits piercing the pale sky. It is the sound that truly captures you here. The resonant, mournful howl of the wind as it sweeps through the valleys and over the jagged rocks, a sound that has echoed through these mountains for hundreds of thousands of years. This is the very call of the Altai, the homeland of the Denisovans, a landscape they not only survived but thrived in, long before our species ventured so deeply into such unforgiving territories. Imagine the Denisovans hearing this very wind, feeling its brutal force yet finding solace and sustenance within these formidable surroundings. Their physiological adaptations, inferred from genetic analysis, paint a picture of individuals with massive jaws, broad faces, and enormous teeth. A robust physique ideally suited for enduring the extreme cold and accessing tough food resources of Ice Age Siberia. They were adapted to extreme environments in ways we're only beginning to understand, mastering a world that challenged even the hardiest of life forms. Why did we find them in Siberia's most inhospitable caves? Because these caves were not merely shelters, they were ancient bastions against the ceaseless frozen elements. The wind carries whispers of Ice Age megafauna that once roamed these valleys, of woolly mammoths and rhinos against which Denisovans must have tested their ingenuity and strength. Their presence here, enduring until potentially 30,000 years ago, overlaps with periods when modern humans were also migrating across Asia. They were contemporaries, sharing this planet with us for millennia. Their resilience, a silent testament to an extraordinary capacity for human adaptability. Most of what we know of their enduring legacy comes from a single cave, yet these mountains are their unspoken monument. This resonant sound of the wind through the mountains is a living echo of their presence, a reminder of a profound mystery. What did the world look like through their eyes as they gazed upon these same peaks? What stories would they tell of surviving the Ice Age in Siberia's frozen darkness, their very existence a triumph against overwhelming odds? Their whispers may be in our DNA, but their spirit seems to linger in the unyielding call of the Altai. You stand in the hushed, sterile environment of a modern, ancient DNA laboratory, a place where the smallest fragments hold the greatest secrets. Here, the biting winds of Siberia are replaced by the soft hum of sophisticated machinery, and the vastness of the Altai Mountains condensed into a tiny, precious piece of bone. The task at hand is nothing short of scientific alchemy, decoding the ancient code, extracting DNA from fossilized fragments tens of thousands of years old. Imagine the delicacy required. From that initial, minuscule fingerbone fragment belonging to a juvenile female, only a speck of powder is carefully drilled. This powder is then subjected to a series of chemical washes and purifications, designed to separate the precious ancient DNA from contaminants, including modern human DNA from archaeologists themselves. It's a precise, exacting process where every step is critical. How do you extract 50,000-year-old DNA from such a tiny sample, knowing it's degraded and fragmented? The answer lies in pioneering techniques and revolutionary sequencing breakthroughs that can read even the most damaged genetic code. The cold, stable environment of Denisova Cave, nestled in Siberia's extreme temperatures, played a crucial role in this preservation. It acted as a natural freezer, maintaining the integrity of the genetic material far better than in warmer, more humid climates. This unique environmental context allowed geneticists to pull forth an entire human species from a handful of cells, unveiling the Denisovans. Their genetic analysis revealed their distinct lineage, their interbreeding with modern humans, and even clues to their physical appearance, like massive jaws and broad faces. This process is a scientific detective story of unprecedented scale, allowing us to connect directly with relatives from hundreds of thousands of years ago. It shows that even with so few physical remains, all known Denisovan fossils could fit in a small box, the genetic evidence can construct a rich, detailed picture. What other ancient genetic codes lie hidden within similar fragments across the globe, waiting for technology to catch up with their silent whispers? What unknown human species, long vanished, could still be waiting to be decoded from the very dust of the earth? You stand at the mouth of Denisova Cave, looking out over the vast, silent wilderness of the Altai, and for a moment you can almost feel the presence of different human footsteps echoing across the ages. This cave is extraordinary, a rare sanctuary where, over tens of thousands of years, at least 3 different human species sought shelter: Denisovans, Neanderthals, and early Homo sapiens. Imagine the profound mystery of these shared spaces, envisioning encounters between these distinct hominin groups in the frozen heart of ancient Siberia. Evidence from the meticulously excavated layers of Denisova cave confirms overlapping occupations. Here, in the very same earth, lie fragments and genetic traces from all 3 populations, sometimes within the same stratigraphic horizons. This isn't just about coexistence. Genetic analysis has offered undeniable proof of interbreeding, most strikingly with the discovery of Deni, the fossilized bone of a first-generation hybrid with a Neanderthal mother and a Denisovan father. This single fragment shatters any simplistic notion of isolated evolutionary paths, revealing a deeply intertwined human story where different lineages met, mingled, and even created offspring. What did these encounters entail? Did they share the warmth of a common fire, trade knowledge of hunting grounds or tool-making techniques, or perhaps clash over precious resources in a world defined by extreme cold and Ice Age megafauna? Both Denisovans and Neanderthals were uniquely adapted to these harsh environments, surviving in ways we're only beginning to understand, exhibiting sophisticated tool use and resilience. When early modern humans arrived in Asia, they too entered this complex landscape of established hominin populations. This shared silence of the cave now holds the echoes of their meetings. What was the nature of their interactions, which led not only to genetic exchange but potentially to a cross-pollination of cultures and technologies? How did these different human species perceive one another? What would we learn if we could meet them? And what stories would they tell of sharing the challenging wilderness, of their coexistence, and the eventual, quiet disappearance of all but one lineage from the face of the earth? You stand on the edge of the Siberian permafrost, a vast, frozen expanse that stretches endlessly beneath a pale, distant sky. The ground here is not merely earth. It is a giant, slow-motion freezer, a silent archive of millennia. The biting cold, which once challenged the very survival of our ancient relatives, now acts as an extraordinary preserver, guarding secrets beneath its icy mantle. This profound environmental context is not just a backdrop to the Denisovan story. It is the key to unlocking future chapters. The poignant reality of the Denisovans is that we know they existed, we carry their genes, yet we've found so few physical remains that all known Denisovan fossils could still fit in a small box. Most of what we know comes from a single cave, Denisova, where the stable, frigid temperatures created ideal conditions for the preservation of fragile ancient DNA. But the success of Denisova Cave, and the revelation of multiple Denisovan populations spread across Asia through ghost DNA in modern humans, begs a crucial question. What more lies hidden beneath vast, unexplored swathes of frozen earth? Imagine the immense potential for future discoveries beneath the permafrost, across Siberia, and other high-latitude regions of Asia. The same extreme cold that made survival challenging for our ancestors also created perfect conditions for preserving bone, artifacts, and even environmental DNA in sediments. Cutting-edge archaeological techniques, combined with advances in genetic analysis that can extract 50,000-year-old DNA from mere dust, mean that new finds are not just possible, but probable. We are only beginning to understand the wealth of information held beneath these frozen landscapes, What would a more complete Denisovan skeleton reveal about their physical appearance, about those massive jaws, broad faces and enormous teeth suggested by genetic reconstructions? What new sites beyond Denisova Cave could emerge from the thawing permafrost, offering direct evidence of their sophisticated tool use or symbolic behavior? What hidden chapters of human diversity and adaptation, preserved by the very elements that shaped them, await discovery in Earth's coldest, most inhospitable realms? You stand beneath the vast, inky expanse of the Siberian night sky, countless stars blazing with an ancient brilliance. Just as they did for our Denisovan relatives tens of thousands of years ago, the air is crisp, carrying the scent of frost and deep time. As you gaze at the constellations, you ponder the precision of the past. How did these early hominins navigate, survive and thrive in such an immense and challenging world, demonstrating an understanding of their environment that allowed for mastery, not just mere endurance? Their very survival in Ice Age Siberia, amidst extreme cold and colossal megafauna, speaks volumes of their intricate knowledge of their surroundings. They adapted to extreme environments in ways we're only beginning to understand, a testament to an intelligence intimately connected to the rhythms of the natural world. This was not a world to be simply endured, it was a world to be understood with profound precision. Their hunting strategies, tracking skills for mammoths and woolly rhinos, and the ability to find refuge in places like Denisova Cave, all point to a sophisticated cognitive map of their vast territories. Further evidence of this precision comes from the artifacts unearthed in Denisova Cave. The polished chlorotolite bracelet, with its carefully drilled hole, speaks of an exactitude in craftsmanship that pushes the boundaries of our understanding of ancient technologies. Similarly, the finely crafted bone needles imply not just skillful hands, but a conceptual understanding of tailored clothing necessary for extreme cold, demonstrating foresight and planning. These objects suggest a mind capable of abstract thought, aesthetic appreciation, and complex problem-solving, far beyond simple survival. This blend of environmental mastery and technological sophistication deepens the scientific mystery. How did these broad-faced, massive-jawed relatives, known primarily from fragments and genetic whispers, achieve such an acute understanding of their world? What astronomical knowledge might they have possessed, navigating by the stars across frozen steppes? What lost wisdom, what precise understanding of their environment, vanished with them? And what profound lessons about human ingenuity and our relationship with Earth might still be gleaned from the subtle, precise echoes of their ancient world? You sit in a quiet space, perhaps tracing a finger over a faded map of ancient Asia. In the vast tapestry of human history, few moments are as profound as the act of naming. A name gives form, a label bestows identity, and for our recently discovered human relatives, the simple word, Denisovan, conjures an entire lineage from the shadows of deep time. It's a name born not from grand expeditions or complete skeletons, but from the most humble of origins, a tiny finger bone found in a remote Siberian cave. The name itself is a whisper from the land, derived from Denisova Cave in Siberia's Altai mountains, the site where, in 2010, that unassuming finger bone fragment was unearthed. This minuscule relic, belonging to a juvenile female, along with a robust molar tooth, provided the first tangible evidence. But it was the revolutionary genetic analysis that truly allowed us to bestow a name, revealing an entirely new, distinct human species. This is the scientific detective story in its purest form. How do you give a name, a unique identity, to a species known mostly from a speck of bone and the ancient code within it? The cultural impact of this name is immense. It forces us to rewrite our family tree, placing the Denisovans as contemporaries who shared the planet with us for hundreds of thousands of years, interbreeding with our ancestors and even Neanderthals. genetic analysis revealed the stunning reality that we carry their DNA, with modern populations in Melanesia and Tibet bearing testament to their enduring genetic legacy. The name, Denisovan, now encompasses a widespread presence, from the frozen landscapes of Siberia, which they survived in ways we're only beginning to understand, to distant Asian shores, evidenced by multiple distinct populations. This echo of a name brings a poignant reality into focus. We know Denisovans existed, we carry their genes, yet we've found so few physical remains that all known Denisovan fossils could fit in a small box. Most of what we understand comes from this, ghost DNA. What would we learn if we could meet them, these broad-faced, massive-jawed relatives, whose existence is so tied to a single cave's name? What other human species, as yet unnamed, still lie hidden in the Earth's silent archives, waiting for their own whisper of discovery to bring them into being? You stand before a vast, intricate mural, not painted on a wall but woven into the very fabric of our species. The discovery of the Denisovans, initially from a tiny finger bone in a Siberian cave, has unveiled a story far grander and more interconnected than we ever imagined. It forces us to look beyond the individual bone, beyond the single cave, to a broader narrative of human diversity and profound interconnectedness that reshapes our understanding of who we are. The defining revelation of the Denisovans is not just their existence, but their intimate relationship with our Homo sapiens * ancestors. Genetic analysis has unequivocally shown that Denisovans interbred with modern humans on multiple occasions across Asia. Today we carry their DNA. Specific populations, like those in Melanesia, hold significant percentages of Denisovan genes, a living testament to these ancient unions. This pattern of interbreeding, which also occurred with Neanderthals, reveals that our human family tree is less a branching diagram and more a complex, interwoven network of ancestral rivers flowing into a common sea. These genetic legacies were not merely echoes, they were often advantageous adaptations. Consider the extraordinary resilience of Tibetans at high altitudes. Genetic analysis revealed that the Times EPAS1* gene, crucial for their survival in thin air, originated from Denisovans. This speaks volumes about Denisovan survival in extreme environments, demonstrating how their long-honed adaptations to cold and altitude could be passed on, enabling Homo sapiens * to conquer new, challenging territories. This idea of humanity as a mosaic enriched by genes from diverse ancient relatives changes everything. Most of what we know about Denisovans, including the stunning revelation that multiple distinct populations existed across Asia, comes from this, ghost DNA. Genetic signatures in modern populations proving ancient interbreeding, even when we've found no physical fossils. It is a poignant reality that these powerful, resilient relatives, who walked the same earth and shared genes with us for millennia, vanished, leaving only these whispers in our DNA and fragments in frozen caves. What profound questions does their existence raise about the true extent of human diversity, adaptation, and what secrets of our own multifaceted origins still lie hidden within the ancient code of our very being? You stand within the cool, hushed depths of Denisova cave, a profound silence, broken only by the gentle drip of unseen water. Before you, a colossal cross-section of Earth rises, a vibrant, layered chronicle that captures millennia in its shifting hues and textures. This is the geologist's palette, the rich stratigraphy of the cave, revealing an unbroken record of human and environmental history stretching back over 300,000 years. Each distinct band of sediment, from the reddish-brown clays to the lighter, ash-rich deposits, tells a silent story of ancient fires, shifting climates, and the successive occupations of different human lineages. This layered archive is invaluable. Meticulous archaeological and genetic analysis of these strata reveals distinct periods when Denisovans occupied the cave, their DNA embedded directly in the ancient sediments, even in layers where no bones were found. These genetic whispers demonstrate their enduring presence here for hundreds of thousands of years, adapting to extreme environments and mastering the harsh Ice Age conditions of Siberia in ways we're only beginning to understand. The preservation afforded by the cave's stable, frigid temperatures is extraordinary, turning Earth into a fragile, invaluable book of time. What is truly astonishing is that this chronicle is not singular. Within these very layers, archaeologists have found evidence of Neanderthals, sometimes in layers that overlap with Denisovan presence, and later, traces of early Homo sapiens. This means that for vast stretches of deep time, this single cave was a shared sanctuary, a meeting point where multiple human species coexisted, perhaps not simultaneously, but sequentially, or in alternating patterns across millennia. This complex pattern of occupation further deepens the mystery of their interactions and eventual fates. This ancient geological record, more than any individual fossil, highlights the profound diversity and adaptability of early human populations. What deeper secrets lie within the unexcavated layers of this extraordinary cave? What unknown environmental shifts or momentous encounters, meticulously recorded in this silent chronicle of time, still await their revelation, further reshaping our understanding of the mysterious humans who sought refuge beneath the Altai peaks? You stand in the heart of Denisova Cave, in the ancient layers marked by ash and charcoal. Here the biting cold of Siberia momentarily recedes, replaced by the ghost of warmth, by the lingering scent of unseen fires. It is the contemplation of fire's glow that allows us to truly imagine the daily lives and extraordinary survival of the Denisovans in one of Earth's harshest environments. Fire was not merely a convenience, it was a lifeline, a central pillar of their existence throughout the Ice Age. Imagine the flickering flames casting dancing shadows on the cave walls, providing not just heat against the extreme cold, but also protection from formidable Ice Age megafauna that roamed the Altai mountains. Archaeological evidence from Denisova Cave consistently shows hearth features and layers of ash, dating back hundreds of thousands of years, indicating continuous and controlled use of fire. This mastery of fire was fundamental to Denisovan survival, enabling them to cook food, sterilize water, and harden tooltips, crucial adaptations in a world of limited resources. Beyond its practical applications, fire held profound social and cultural significance. Gathered around its warmth, these broad-faced, massive-jawed relatives, whose appearance is inferred from genetic analysis, would have shared stories, planned hunts, and perhaps even engaged in the symbolic behaviors suggested by artifacts like the polished bracelet found in the same layers. Fire would have been the focal point of their communities, a beacon of safety and connection in the vast, frozen darkness of Siberia. They survived in ways we're only beginning to understand, and fire was surely a key component of their ingenuity. Most of what we know about their long occupation comes from a single cave, a testament to the power of such concentrated archaeological sites. What untold stories of community and resilience were forged in the heat of those ancient fires? What social structures, what forms of communication, developed in the glow of the flames that kept them alive through endless Siberian winters? And what does the enduring symbol of fire, a shared human inheritance, tell us about the profound connection to these enigmatic relatives, who, like us, found meaning and survival in its radiant embrace? You stand in the hushed, almost reverent quiet of an ancient DNA laboratory, the precise instruments gleaming under focused lights. The air is still, a stark contrast to the biting winds of Siberia. Here, the story of the Denisovans, so profoundly mysterious, began its modern revelation not with a grand excavation, but with the meticulous, patient quest of scientists dedicated to decoding the deepest past. This is the heart of the scientific detective story, where years of intellectual dedication converge on understanding an entire human species from the most fragile of clues. Imagine the countless hours spent refining techniques, battling contamination, and painstakingly extracting genetic material from a tiny fingerbone fragment, barely larger than a speck. This minuscule relic, found in Denisova Cave, was a treasure, but its ancient DNA was degraded, fragmented by tens of thousands of years. The challenge was immense. How do you reconstruct an entire human species from such minute, damaged genetic whispers? It demanded revolutionary sequencing breakthroughs and an unwavering commitment to precision. Genetic analysis, a marvel of modern molecular archaeology, was the key, turning invisible molecules into a vivid chronicle. The dedication extends beyond the lab, back to the frozen landscape of Siberia's Altai mountains. Paleoanthropologists, with equal patience, meticulously sifting through meters of cold, compacted sediment in Denisova Cave, carefully noting every layer, every tiny anomaly. This crucial environmental context, the extreme cold, served as nature's perfect preserver, allowing the precious DNA to survive where it would have long vanished elsewhere. It's this combined dedication, from the arduous fieldwork to the intricate laboratory science, that brought the Denisovans from absolute obscurity into the limelight of human history. This profound dedication unveiled a species that interbred with modern humans, leaving their DNA in us, particularly in populations like those in Melanesia and Tibet, who carry crucial high-altitude adaptations from them. It revealed their survival in ways we're only beginning to understand, a story of immense adaptability against Ice Age megafauna and brutal temperatures. What future mysteries, what other unknown human species, or lost chapters of our own past, might still be waiting to be revealed through such unwavering scientific quests, born of patience, precision, and an insatiable curiosity for the silent stories of deep time? You hold a replica of the polished stone bracelet from Denisova Cave, its cool, dark green surface perfectly smooth beneath your fingertips. Close your eyes and imagine another hand, tens of thousands of years ago, holding this very stone. Feel the grit as it was first shaped, the slow, rhythmic abrasion that gradually wore away imperfections, revealing the hidden luster within the chloritolite. Imagine the focus, the patience, the dedication of the artisan, perhaps a young Denisovan female, meticulously grinding and polishing for countless hours in the flickering firelight of the Ice Age cave. This isn't just an artifact, it's a profound whisper of an individual mind. This exquisite fragment of a bracelet, dated to an astonishing 40,000 to 50,000 years ago, challenges our deepest assumptions about cognitive capabilities in ancient human relatives. Its precisely drilled hole and meticulously polished surface speak volumes of advanced craftsmanship and a sensibility beyond mere utility. For mainstream archaeology, such symbolic behavior and sophisticated tool use were once thought to be exclusive to tight Homo sapiens. Yet this piece, found in layers undeniably associated with Denisovan remains, now suggests a complex inner world, an aesthetic appreciation, and perhaps even individual expression or social signaling among these enigmatic people. The making of this bracelet was no simple task. It required not just skill and specialized tools for grinding and drilling, but also foresight, planning, and a deep understanding of material properties. It hints at a society that valued beauty, perhaps status, and certainly individual adornment. These were robust, massive-jawed relatives, whose appearance is inferred from genetic analysis, yet they possessed hands capable of such delicate, precise artistry. They survived the harsh Ice Age of Siberia, but they also created beauty, adding another layer to the profound mystery of their complex lives. We know Denisovans existed, we carry their genes, yet we've found so few physical remains that all known Denisovan fossils could fit in a small box. Most of what we know comes from their ghost DNA and these rare silent artifacts. What thoughts ran through the artisan's mind as they shaped this stone? What did this bracelet mean to the person who wore it in Siberia's frozen darkness? And what profound insights into the capacity for beauty and symbolic thought in our ancient relatives does this single, polished fragment now quietly offer us? You find yourself gazing at a map of ancient Southeast Asia, not of modern islands, but of vastly different land bridges and coastlines shaped by fluctuating sea levels. The air here is humid, carrying the scent of tropical forests and a profound sense of distance from the frozen Siberian mountains where the Denisovan story began. Yet, it is precisely here, in the distant islands of this region, that the most tantalizing evidence of widespread Denisovan presence emerges, a profound expansion far beyond their initial discovery site. Genetic analysis, a powerful lens into the past, has revealed that modern indigenous populations in Southeast Asian islands, particularly in places like Papua New Guinea and the Philippines, carry significant percentages of Denisovan DNA. We carry their DNA, a living legacy of ancient interbreeding events that unfolded thousands of miles from Denisova Cave. This ghost DNA, genetic signatures in modern populations proving ancient interbreeding even when we found no physical fossils, is the primary evidence for these widespread, unseen migrations. It unequivocally indicates that multiple Denisovan populations, distinct from the Siberian group, existed across Asia. This genetic evidence raises profound questions. How did Denisovans, seemingly adapted to the extreme cold of Siberia, also thrive in the warm, humid, and entirely different ecosystems of island Southeast Asia? This immense adaptability speaks volumes about their versatility and resilience. Their physiological features, inferred from DNA, suggesting massive jaws, broad faces, and enormous teeth, might have served them well in diverse environments, but the sheer ecological breadth is astonishing. The almost complete absence of physical Denisovan fossils in Southeast Asia deepens the mystery. Despite their strong genetic legacy in modern populations, no definitive Denisovan skeletal remains have been found there to date. What unknown caves or ancient settlements might hold the physical proof of their lives in these tropical realms? What stories of unique adaptations, of navigating ancient archipelagos, and of cultural encounters with our ancestors lie buried in the humid earth of these distant islands, waiting to reveal a wider canvas of Denisovan influence and the extraordinary complexity of our shared human past? You stand in the thin, crisp air of the Tibetan plateau, not in a cave, but before a remarkable relic that reshaped the Denisovan story, a fragment of a mandible, a lower jawbone. This find, unearthed in Baishir Kast Cave at an astonishing altitude of 280 meters, offered the first definitive Denisovan fossil outside of Siberia. The stone is cool and heavy in your imagination, its robust form, speaking of a powerful ancient being who once chewed and spoke in this very place, hundreds of thousands of years ago. This enigmatic jawbone, dated to approximately 160,000 years old, is strikingly massive and robust, featuring a deep body and large molars, traits characteristic of archaic humans. Its sheer size aligns perfectly with earlier reconstructions based on genetic analysis from the Siberian fingerbone, which suggested Denisovans possessed powerful jaws, broad faces, and enormous teeth. Here, the ghost DNA, whispers from modern populations, finally met a tangible, powerful bone, offering a crucial physical confirmation of their formidable physique and extending their known range dramatically. The location of this jawbone is profoundly significant. Found at such an extreme high altitude, it provides direct archaeological evidence for what genetic analysis had already hinted at: Denisovan adaptation to challenging, low-oxygen environments. It solidifies the theory that Denisovans were indeed mountain specialists, whose genetic legacy, including the Times EPAS1* gene, later enabled modern Tibetans to thrive in similar conditions. This jawbone tells a story of an ancient species not just surviving, but mastering the high-altitude world long before Homo sapiens* arrived. This single jawbone, though still a fragment, unlocks new insights into Denisovan resilience and geographical spread, illustrating that multiple Denisovan populations existed across Asia, from frozen Siberia to the roof of the world. What was life like for these robust relatives in such breathtaking, yet demanding landscapes? What additional powerful fossils might still lie hidden within the sacred mountains of Tibet, waiting to fully reveal the physical majesty and untold stories of these mysterious humans who once roamed and thrived where few could follow? You gaze upon a visual representation of the human family tree, but it's no longer a neat, linear progression. Instead, it's a complex interwoven tapestry, a dense thicket of branches, many of them crisscrossing and merging. The discovery of the Denisovans, springing from a tiny finger bone in a Siberian cave, has fundamentally reshaped this understanding, revealing a truly intricate crossroads of evolution where multiple human species coexisted, interacted, and interbred. The profound mystery lies in this genetic intermingling. We now know, thanks to cutting-edge genetic analysis, that modern humans interbred not just with Neanderthals, but with at least 3 different human species, including Denisovans, and possibly other, older ghost hominins, yet to be physically identified. This implies a far more complex and dynamic prehistory than previously conceived, where distinct human lineages encountered each other, exchanged genes, and contributed to the rich genetic diversity we see today. The evidence is undeniable. We carry their DNA, with populations like those in Melanesia and Tibet, bearing undeniable Denisovan genetic legacies. This intertwined family tree challenges traditional definitions of what it means to be human, and the concept of distinct species. If different hominin groups could interbreed and produce fertile offspring, sharing genetic adaptations like the Tibetan Times EPAS1* gene for high-altitude survival, where do the boundaries truly lie? The Denisovans, who survived the harshest environments on Earth in ways we're only beginning to understand, demonstrate a remarkable adaptability that was then passed on to our own ancestors, proving the profound benefits of this genetic exchange. This revelation from a handful of fragments and the silent whispers of DNA from a single cave in Siberia makes us question everything we thought we knew about our origins. How many other human species existed that left no trace in the conventional fossil record, known only through their fleeting genetic echoes within us? What profound implications does this complex interbreeding have for our understanding of human diversity, resilience, and the true multifaceted nature of our shared ancestry, making our family tree a far more intricate and mysterious chronicle than we could have ever imagined? You hold the polished stone bracelet fragment, its smooth surface cool against your skin, and you realize you're touching not just an ancient object, but a tangible question. This exquisite piece, unearthed from Denisova cave, and dating back up to 50,000 years ago, is more than an artifact. It is an unspoken language, an enigma of symbolic meaning from a human species whose very existence remained unknown until recently. How do we interpret the profound significance behind these early adornments? The bracelet, with its perfectly drilled hole and meticulous polish, challenges simplistic notions of early hominin capabilities. Such sophisticated tool use and symbolic behavior, once almost exclusively attributed to Homo sapiens*, now clearly extend to the Denisovans. This speaks to a mind capable of abstract thought, aesthetic appreciation, and perhaps complex social signaling. They were not just surviving the harsh environments of Ice Age Siberia, but creating beauty and meaning within their challenging world. This capacity for symbolic expression is a profound mystery for a species known largely from genetic fragments and a handful of bones. Fossil artifacts from Denisova cave like small bone needles and ostrich eggshell beads further support the idea of a rich material culture, pushing the timeline of such sophistication much further back and questioning the linearity of human cognitive development. What was the unspoken language of these adornments? Did the bracelet signify status, group identity, or a spiritual connection? Did it represent an individual's unique story, a cherished possession in the brutal, frozen landscape of their existence? Most of what we know about the Denisovans comes from a single cave, their ghost DNA living on in us, a testament to their deep legacy. Yet, these artifacts are rare, poignant physical links. What profound questions does this symbolic behavior raise about human diversity, adaptation, and what we still don't know about the inner lives of our own family tree? If we could meet them, these broad-faced, massive-jawed relatives, what stories would these silent, beautiful objects prompt them to tell of their world, their culture, and the meanings they ascribe to existence in Siberia's frozen darkness? You sit in a quiet laboratory, not with ancient bones, but with screens glowing with intricate data, a testament to the accelerating pace of scientific discovery. The story of the Denisovans, once a mere whisper from a single Siberian cave, is now being rapidly fleshed out by emerging technologies that are revolutionizing paleoanthropology. We are moving beyond the shovel and trowel alone, entering an era where the future of our past is illuminated by unprecedented scientific prowess. Central to this revolution is the refinement of ancient DNA sequencing, allowing geneticists to extract and analyze incredibly degraded genetic material. From that tiny fingerbone fragment found in Denisova cave, to a robust molar, and later a jawbone from Tibet, each piece has yielded its secrets, thanks to these breakthroughs. But even more astonishing is the ability to extract environmental DNA, or eDNA, directly from cave sediments. Imagine geneticists sifting through ancient dust, not for bones but for the microscopic traces of skin cells, hair or waste, left by our ancestors tens of thousands of years ago. This technology reveals the presence of Denisovans in layers where no physical fossils exist, providing ghost DNA, evidence of their long occupation. Beyond DNA, new techniques like paleoproteomics, the study of ancient proteins, offer another powerful lens. Proteins, more robust than DNA, can survive longer in adverse conditions, providing complementary information about species identification and even diet. These methods are critical for reconstructing an entire human species, like the Denisovans, who left so few physical remains that all known fossils could fit in a small box. They allow us to infer their massive jaws, broad faces, and enormous teeth, and understand how they adapted to extreme environments in ways we're only beginning to comprehend, thriving in Ice Age Siberia. What does the horizon hold for uncovering more about these mysterious relatives? Will advanced imaging techniques reveal hidden details within existing fragments? Can AI algorithms analyze subtle patterns in sediment to predict new fossil locations? These emerging technologies promise to unveil more widespread Denisovan populations across Asia, and perhaps even entirely new, currently unknown human species. What profound secrets of human diversity and adaptation still lie hidden, waiting for the cutting edge of science to give them a voice, further enriching the complex, captivating story of our deep past? You close your eyes, the last echoes of the Altai wind fading into a profound silence. Our journey through the enigmatic world of the Denisovans, those recently discovered human relatives who survived in Earth's harshest environments, leaves us with a sense of wonder, but also a deep appreciation for the enduring mystery that still shrouds their story. We began with a single, tiny fingerbone fragment, unearthed in a Siberian cave in 2010, and from that speck, an entire human species emerged from the shadows of deep time. The core of the mystery remains profound. We shared the planet with them for hundreds of thousands of years, our contemporaries walking the same Earth, yet we only discovered they existed a mere decade ago. This scientific detective story, reconstructing an entire human species from a fingertip, a robust molar, and a high-altitude jawbone, is nothing short of revolutionary. Genetic analysis, powered by stunning sequencing breakthroughs, revealed their distinct lineage, their widespread presence as multiple populations across Asia, and the undeniable truth that we carry their DNA today. Their resilience is awe-inspiring. They adapted to extreme environments in ways we're only beginning to understand, thriving in Ice Age Siberia, enduring brutal cold and formidable megafauna. Their genetic gifts, like the Times EPAS1* variant for high-altitude adaptation, live on in modern Tibetans, a silent testament to their mastery of challenging landscapes. Artifacts from Denisova cave hint at sophisticated tool use and symbolic behavior, portraying a complex intelligence that created polished bracelets and delicate bone needles. We even have direct evidence of interbreeding with Neanderthals and modern humans, weaving a richly intricate tapestry of our shared past. Yet, despite these breakthroughs, the poignant reality persists. We know Denisovans existed, we carry their genes, but we found so few physical remains that all known Denisovan fossils could fit in a small box. Most evidence comes from ghost DNA, genetic signatures proving ancient interbreeding, even when no fossils have been unearthed. They vanished, leaving only whispers in our DNA and fragments in frozen caves. How many other human species existed that left no trace? What truly led to their extinction after millennia of thriving? What would we learn if we could meet them, these broad-faced, massive-jawed relatives, and hear their untold stories of surviving the Ice Age in Siberia's frozen darkness? The story of the Denisovans is far from finished, an enduring mystery that continues to challenge and expand our understanding of what it means to be human.